Suppose the sun expands so that its radius becomes 100 times its present radius. So assume that the radius in the first situation was nothing but r, then the radius in second situation becomes equal to 100 times of r or 100r. And its surface temperature becomes half of its present value. That means assume that initial surface temperature was T, now the surface temperature becomes equal to T divided by 2. The total energy emitted by it then will increase by a factor. So our aim is to find out what about the value of energy emitted by this object. So if you are using that equation for amount of energy radiated per second, E sigma A, temperature of object raised to 4. So you can write this is equal to E into sigma into A represents the surface area of a sphere. We can take it as 4 pi r square into temperature of object raised to 4. So the power radiated is basically directly proportional to r square and temperature of object raised to 4. So you can say that power in second situation by power in first situation will be equal to R2 divided by R1 raised to 2 into T2 divided by T1 raised to 4. So you can write the value of R2. The value of R2 is given as nothing but 100R, and the value of R1 is given as nothing but R the whole square into the value of T2 is given as nothing but T divided by 2, and T1 is given as nothing but T. So this T get cancelled and this R get cancelled. So you can write it will be, and this one raised to 4. So this will be 100 raised to 2, which we can take it as 100 into 100 or 10,000 divided by 2 raised to 4, which we can take it as 16, which is equal to 625.